gliding over potholes and bumps without feeling a single vibration. This is the goal of active suspension, turning standard roads into a magic carpet ride. Traditional suspension is reactive. It uses springs and oil dampers that can only absorb shock energy after your wheels have already crashed into a bump. It is like a blindfolded walker tapping the path ahead with a cane. They only know they hit a deep pothole after their foot drops, causing a stumble. An active suspension is like an athlete wearing smart glasses. They scan the path ahead, spot the stones, and adjust their steps to glide over them. To understand active suspension, we need to divide a vehicle's weight into two categories: sprung mass and unsprung mass. Sprung mass is everything supported by the car's springs. This includes the car body, the engine, the chassis, and the passengers inside. Unsprung mass is everything below the springs: the wheels, the heavy rubber tires, the brake assemblies, and the suspension links. Imagine hiking. Wearing heavy boots is like having high unsprung mass, slamming shock into your knees. Wearing sneakers lets you step lightly. Active suspension isolates the sprung cabin from the wheels, allowing the tires to bounce over bumps while the passengers float completely still. How does the car see a pothole? It uses stereo cameras and LiDAR units mounted behind the windshield to scan the road surface in real time. These sensors act like a scout running 15 meters ahead of the car, mapping every bump and dip down to just a few millimeters. In systems like Magic Body Control, the car doesn't bounce over speed bumps. Instead, it predicts them and adjusts its wheels dynamically. When the car approaches a bump, the computer commands actuators to lift the wheel just as it passes over, then push it back down. Instead of colliding with the bump, the wheel steps right over it. The cabin stays completely level while the wheel moves beneath it. While the tires follow a rough wave contour, the cabin tracks a perfectly flat line, eliminating vertical force spikes entirely. This requires a tight control loop called Model Predictive Control. The computer processes the scans and sends fast commands to the actuators. Traditional hydraulic dampers are slow. They rely on pushing pistons through sticky oil, which creates a physical delay. Electromagnetic dampers solve this using electric motors and copper coils, generating magnetic forces to move the wheel instantly. Instead of pushing against oil, the system acts like a magnetic tractor beam, applying instant counterforces to neutralize bumps. This system can actually harvest energy. When a bump forces the wheel up, the actuator acts as a generator, recovering power. By converting mechanical shocks into electricity, it feeds power back into the car battery, offsetting its own energy consumption. How fast is this math? A typical human blink takes about 100 milliseconds, far too slow to react to high-frequency road bumps. Active suspension adjusts in just 1 millisecond. That means it can make 400 adjustments in the time it takes you to blink once. By applying matching opposite forces, the struts cancel out high-frequency road vibrations before they can shake the cabin. This speed is vital for comfort. Human bodies are not solid. Our internal organs and spine have natural resonance frequencies. Our internal organs wobble at 4 to 8 Hz. When a car bounces in this range, it shakes our organs, triggering motion sickness. These resonant vibrations exhaust our muscles and confuse the brain's balance centers, causing severe fatigue on long road trips. Active suspension fights 3 types of motion: heave, which is vertical bounce; pitch, which is tilt during braking; and roll, during cornering. By applying stabilizing counterforces, the active struts keep the cabin completely flat and steady during high-speed cornering. So why isn't this on every car? These systems cost between $0 and $0, limiting them to luxury flagships. The technology was pioneered by Bose in the 1980s. Although their early setups were too heavy, they laid the foundation for modern designs. Modern flagship apps use 48-volt systems to power fast-acting electric pumps, bringing this magic carpet ride to production cars. At Layman's field, we believe that understanding technology shouldn't require a doctorate. We break down the engineering behind these breakthroughs for everyone. By predicting potholes before hitting them, active suspension is redefining ride comfort. Thank you for watching Layman's Field, bringing knowledge for everyone.